So today we are going to continue talking about atoms and how they bond to one another. We've already talked about the general structure of atoms and how they have a nucleus, the center of the atom, which contains the positive protons, neutral neutrons, and then the electrons, which are negative, are moving around the nucleus in what we call shells or orbitals. Atoms are unique to the element that they are. So, for example, an atom of hydrogen looks different from an atom of gold. And when they do combine with each other, when they come together forming a bond, they have a different property than if they were just alone on their own. So today we're mostly going to be focusing on chemical bonding. And it says here this is just the attractive force that exists between the atoms. That's a chemical bond. Covalent bond is the type of bond when two atoms are coming together and they are sharing electrons. And this was first explained by Gilbert N. Lewis in 1916. And he was realizing that when hydrogen atoms come together, they are much more stable. And he also came up with this way to draw out the atoms and show how they are coming together and sharing their electrons. This is called the Lewis dot structure, or just Lewis structures. You do not need to know how to do this. You just have to be aware of its existence, and you mostly need to know how to do the Bohr models, which we have already done. When it comes to the electrons that are flying around the outside of atoms, they can be broken into two categories. We have core electrons and valence electrons. The core electrons can just be called the inner electrons. They are the electrons that are they're in the inner shells, and they have valence electrons that are on the outside of them. Sharing of electrons will take place in the valence shell with the valence electrons. Or we could say the outermost electrons are the electrons that will be used in the bonding of atoms. And a definition on this slide that you need to know is covalent bonding. It says the result of chemical bonding of atoms that share pairs of valence electrons. So when two atoms come together to share electrons, this is happening with the valence electrons, and the bond they form is covalent bonding. Sharing electrons, covalent bonding. I will often say sharing is caring. This is covalent bonding. There are three types of covalent bonds, and they are pretty straightforward. We have a single bond, which is formed when two atoms share just one pair of electrons. A double bond, when two atoms share two electrons. And then a triple bond, when two atoms share three, so they're each sharing three. The number of valence electrons are associated with the number of covalent bonds the atom can form. So just depending on the valence electrons that are in the outer shell of a particular atom, it's going to change the number of covalent bonds that the atom wants to form in an ideal situation for that atom. The octet rule says that atoms want to have a full outer shell, and typically, with the exception of the small inner shell, that means 8 valence electrons. So this says, in forming compounds, atoms gain, lose, or share electrons to give a stable electron configuration characterized by 8 valence electrons. So the atoms are either going to share with an atom or they're going to get rid of them, but they're going to do what they can to get to 8. So here's an example of a single covalent bond. So fluorine has 9 electrons, so 2 are going to be in the inner shell. That leaves 7 for the next shell, which means there's 7 valence electrons. how many electrons does it need to have a full shell? So it wants to get to 8, so it just needs one more. So we could have 2 fluorine atoms coming together to each share an electron with the other atom, and now they each have 8. So this is an example of a single covalent bond. They're each sharing 1, and now they're happy. An example of a double covalent bond would be CO2. This should sound familiar to you. Do you know what this is? It is carbon dioxide. So when you look at this picture, you see that each atom is actually sharing 2 electrons. And this is called a double covalent bond. They are all of these atoms are happy because now they have 8 electrons in their outer shell. You can go ahead and count them up. If you don't believe me, there are 8 in the outer shell. So they are happy. How many double bonds are in CO2? The answer would be 2. The carbon atom forms a double bond with each oxygen atom. The last thing we have to talk about are polar covalent bonds. So normally, in the previous slides, the atoms are sharing their electrons and they're all happy and they're all playing by the rules and it's all fair, evenly distributed. But in polar covalent bonds, the electrons are not evenly shared. So it says the electrons between the atoms are attracted more strongly to one atom over the other. And so since it's not balanced, that means that the charge of the overall molecule is not balanced. So this says if the electrons are not evenly shared, what happens to the overall charge of the molecule? What charge do electrons have? You should be answering negative. Electrons are negative. So whichever atom is hogging the electrons more is going to be the more negative side in the molecule. So over here in this picture, we have a chlorine atom has formed a bond with a hydrogen atom. But the chlorine is being more of a hog and kind of stealing more of the electrons and keeping it on its end of the molecule. So this is a polar covalent bond. The chlorine atom is a little bit more negative than the hydrogen bond, even though they're still stuck together. They're still a molecule, but it's just a little bit uneven. So here's another picture that shows this example. So we have H2O. When you look at the oxygen end of this molecule, you should see that there are all of the electrons. All of the electrons are on the oxygen end. And we know that electrons are negative. So that oxygen end is slightly negative, and the hydrogen end that does not have electrons on it would be slightly positive. This concludes your bonding notes.